Hello all. Till now, we have finished the logical operator, arithmetic operation, and various comparator blocks in a Matlab Simulink. Okay. Now we will start with if-else condition. If we want to implement in a Simulink, how we can implement. So before we are proceeding to if-else condition, we have to learn one which block name is switch. Okay. So where you will find that switch block in a Simulink. In signal routing, you can come down a little bit. Here you are able to find this switch block. Okay. I am taking this switch block here. First, I will explain you what is the switch block. Switch block is like a switch like switch output, like in between like first and third input. That first and third are the input, and the value based upon the second input. According to second input, what output should be taken is decided by switch block. So this second input as a condition which work for it, and first and third should be our like inputs. Okay, what we want according to that. So if I want to know much more about switch block, the switch block passes through the first input or the third input based on the value of second input. The first and third input are called data inputs, and second input is called control input. Specify the condition under which the block passes the first input by using the criteria of passing the first input and threshold parameters. To immediately back propagate a known output data type to the first and third input ports. Okay, set the output ports and to the inherits and internal rules. Okay, so here the important thing is require all data ports input to have the same data types to be checked. Okay, fine. This is our switch input. What I have told, that second input should be worked as an for first two inputs are the input ports, and second one is like control input. Okay, so how can I show you? Okay, basically I'll take one sine wave generator. Sorry, sine wave. Okay, normally I am connecting this as a first input. Another input I am taking as a square wave generator. I am connecting as a third input to the switch and taking one constant, okay, and connecting to the second input, which is the control input, and first two are the data inputs, where we can say. Okay, so here how it will work, I'll show you. Here you can simply read passes to the first and second input satisfy the selected criteria. There are three criteria. One is greater than threshold, greater than equal to threshold, or not equal to 0. These criteria we will get here, and if we want to change the threshold value, we can change it from here as well. For this scenario, I'll not change the threshold value, I'll make it to 0 only. If in some projection somewhere, we will change this as well. Okay, so we have three scenarios, and where we will see the output of this on a scope. Where we can find a scope in a sync. In Simulink sync, we will find a scope. I will show you here. In Simulink sync, we will find a scope. Okay, I am directly using here to do not make a confusion. I am making you. So here you can look at here. If my switch output is true, okay, my switch output is true, then my first input should be passed. If my switch should be false, then my third input should be passed as an output in this scope. Here, my 1 is greater than 0. So what will happen? My first input should be passed. Here you can see, I am opening the scope. Here, the sine wave should be generated. Okay, for this. Okay, now if I am change this value 1 to the 0, which is not greater than 0, it's 0 means 0. So here the square wave is generated. If I am changing this threshold like greater than or equal to in the scenario, then 0 is equal to 0. Then again, now in the scope, my square wave is there. If I am run this, now my sine wave will come. So in that way, we can use the switch block. Now, here we will try to implement this condition if else. If my u1 is greater than u2, then y1 is equal to u1, else y1 is equal to u2. How can I implement this? For this, we already studied the comparator. I require one relational operator here. So I am taking the relational operator here, one. Okay. Another one, I require the switch for this. I am taking one switch for this. So my relational operator is a control input for this switch here. Okay. And I want two inputs which are constant. Okay. Two inputs which are constant. I'm connecting here. Okay, I'll change the values, no problem. I'll change the input values as well. I'll make it little more simple for this. Here, my U1 is greater than U2. Here, suppose this is my U1 and this is my U2. There, I'll be having two inputs. Okay, here I'll make that equation to the greater than. What's our requirement? If my U1 is greater than U2, then my output should be displayed here. My output I am taking on display. Here, connecting the display. So what are the inputs to the comparator? It's simply connected to this, same as an input. If my U1 is greater than U2, it's compared here. If it's greater than this, then this is passes to this switch. So I'll make one scenario like my U1 is 6, apply, okay, which is, and U2 is like 4, apply, okay. Here you can see my 6 is greater than 4, it's compared here. Then my this switch equation become a true, then my output should be 6. Okay, I'll show you here after simulation. You can see my output should be 6. If I am making this as an 2, if I am making that first U1 as an 2, where in that scenario my if condition will be false, then else should be implemented. That means output should be 4 here. Okay, you can see here output should be 4 here. So in that way, we can implement the if-else condition in Matlab Simulink using a simple blocks like relational operator and switch case. So using all these basic blocks which we have studied till now, we will implement one basic project in the next session.